And this is a lesson on prime numbers and the sieve of Eratosthenes. So there's this guy in Egypt about over 200 years before the Common Era, and he's this librarian in Egypt, and he's kind of playing around with some numbers. He gets out a tablet of stone, and he chisels some numbers into it, and looks kind of like that. And chisel some numbers into it, and he's like, I'm gonna try a little pattern here. Okay, so what he does is he starts with each number. We're gonna not worry about 1 for now because we know that's got some weird properties, but he starts with 2, and he says 2 is prime, so I'm gonna leave it, but I know I'm gonna actually cross out 1 for a second here. He's like, 2 is prime. It only has factors of 2 and 1. But then he takes every number thereafter and he chisels in a little hole, because every multiple of 2, he knows there's no way that's going to be prime because it has more than just factors of itself and 1. It also has a factor of 2. So he chisels in a little hole to all the multiples of 2, 2, 4, 6, 8, etc. Okay, so it starts to look like this. He's got his holes chiseled in. And that one got kind of big. So then he goes to 3. And he's like, I know 3 is prime. It just has multiples of 1 in itself. But then it only has factors of 1 and itself. But all the multiples of 3 going up aren't going to be prime. So I'm going to chisel a hole in. Well, 3 already has one. 9 does not, but it's a multiple of 3, so he chisels in a hole. And 12 does, but 15 doesn't yet, so he chisels in a hole. Then he looks at 4. Okay, we know that's not prime. Then he goes to 5. 5 is prime, so he leaves it. But then he says, but I'm going to do all the multiples of 5. So 10 and 15, they already have holes. Then 6. Then 7. And all the multiples of 7, which is just 14, it already has a hole. Then 8, 9, and so on. He did his with like 100 numbers or 200 numbers even. I'm just showing you 16 for an example. When he got to the end of his stone, he looked back and he said, okay, all the numbers I haven't put a hole in, those are my prime numbers. Okay? So I don't know what he did then, but let's say we chisel a little p in each one that's prime. So prime, 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 and prime. All right, so 2, 3, 5, 7, 11, and 13 are our prime numbers using the sieve of Eratosthenes. 2, 3, 5, 7, 11, and 13. When he got done, he looked back at it and it had all these holes chiseled in it, and he said, that reminds me of a sieve. I don't know if you know what a sieve is. I'll use a green arrow to show you. Right up here is a sieve. It's basically a thing that has a bunch of holes in it to catch some things and let other things go through. It's like a screen. And he thought that it kind of resembled it. A tablet full of holes resembled a sieve. By the way, this right here is a picture of Eratosthenes that he posed for in 240 BCE. So there you have it, the sieve of Eratosthenes. Now the other thing I wanted to show you was what twin primes, okay? Twin primes. And twin primes are simply 2 prime numbers that only have 1 number between them. So 2 and 3 don't have a number between them. They're not twin primes. 3 and 5 have only the number 4 between them. So they are twin primes. Same with 5 and 7. Only the number 6 is between them, so they are twin primes. 7 and 11 have 8, 9, 10 in between them. 11 and 13 only have the number 12 between them, so they are twin primes. So there you have it. The sieve of Eratosthenes right here. Whoa. Wow. That didn't turn into a square. You have Eratosthenes himself. You have an example of twin primes. Here is a more modern day sieve, and that's everything you need to know for this lesson. Thanks for watching.